So for the first problem, we're going to find the solution to the differential equation. We're going to anti-derive f prime of x, and we'll get f of x. Anti-deriving x squared, we'll get 1/3 x cubed plus c. We have the initial condition f of 0 is equal to 1, substituting in f of 0, replacing x with the 0, and replacing f of 0 with 1. Solving for c, we get c is equal to 1. So then our particular solution is f of x is equal to 1/3 x cubed plus 1. In our next problem, the derivative is negative sine x, so we'll just rewrite that as dy dx is equal to negative sine x. Bring the dx up and over to the other side. We'll anti-derive both sides. We'll get the integral of dy is y, and the antiderivative of negative sine x is cosine x plus c. Using the initial condition f of pi is equal to 3. Substituting 3 in for y, and x will be pi. Solving for c, cosine of pi is negative 1, so c is equal to 4. Then our particular solution is y is equal to cosine of x plus 4. Next example, we have the second derivative of f is equal to x squared. We'll anti-derive our second derivative, and that'll become f prime of x, the first derivative, which is equal to 1/3 x cubed plus c. Using the first condition, f prime of 0 is equal to 6. Solving for c, we'll have 6 is equal to c. F prime of x is equal to 1/3 x cubed plus 6. We'll need to anti-derive again to get our f of x. So anti-deriving f prime of x. That's going to be f of x is equal to 1/12 x to the 4th plus 6x plus c. Using the initial condition, f of 0 is equal to 3, substituting in 0 for x. We'll go ahead and solve for c. So the value for c is going to be 3. And our particular solution is f of x is equal to 1/12 x to the 4th plus 6x plus 3. In the problem, the initial size of the population is 500, which means time is equal to 0, the population is 500. After 1 day, the population has grown to 600, so when time is equal to 1, the population is 600, and we'll be estimating the population after 7 days, so that population is unknown. The given differential equation, dp dt, is equal to k square root of t. Multiplying both sides by dt, we'll get dp is equal to k square root of t dt. Anti-deriving both sides, we'll get p is equal to k times 2/3 t to the 3/2 plus c. Using our initial conditions, we'll be able to solve for c and for k. Using population is equal to 500 and time is equal to 0. We're then able to find out that c is equal to 500. Our population equation now has 2/3 k t to the 3/2 plus the population of 500. Using our other initial condition of population is equal to 600 and time is equal to 1, replacing that into our population equation, get 600 equals 2/3 k times 1 to the 3/2 plus 500. Go ahead and then solve that problem for k. And we get the value of k is equal to 150. Now our population equation is equal to 150 times 2/3 t to the 3/2 plus 500. And then using the value of time is equal to 7, we'll be able to solve the value of the population. And then we have our answer.